Hello, my name is Ivan Smirnov. Welcome to Getting Started with Generative AI and Research. So I'm sure that by now you've either tried or at least heard about this new technology, these chatbots that are powered by large language models and that perform remarkably well across a remarkably wide variety of tasks. For instance, now you can ask a computer to generate a rhyming proof that there is an infinite number of prime numbers and it will dutifully oblige. So, we can debate the poetic quality of this output, but not long ago the idea of AI accomplishing something like that would have seemed unimaginable. And in this course we will discuss how this technology, which is called Generative AI because it's generate text or images or videos. So we discuss how this technology works, what is the best way to interact with chatbots, how they can help us in research, and importantly, we also discuss why we should be careful when we're using these technologies. And we'll start by exploring how this technology works. So my goal here is to provide with high-level understanding of the technologies behind Generative AI. And strictly speaking, you don't need this. You can directly jump into a chatbot interface and start interacting with it. But I believe that first of all, it's interesting, and curiosity is something that has been always important for researchers. And also I think it's useful because knowing how these models work will make you a better user of the technology, and it will also help you to be more critical when evaluating statements about them. It doesn't matter if it's like overly negative or overly positive statements. And so the goal for this part is essentially to make sure that all these acronyms that you might encounter nowadays, like AI, ML, NN, GPT, NLP, or LLM, that all these acronyms are demystified and you understand, at least on a high level, what stands behind them. Let's start with AI, or artificial intelligence. There isn't a universally accepted definition of artificial intelligence, but typically it means that we're using computers to solve tasks that would otherwise require human intelligence. I think what's interesting about this definition is that once humans learn how to automate a certain task, they quickly stop considering it smart enough for computers to qualify as artificial intelligence. For example, no one considers calculators AI because it seems to be such a trivial task. You are just counting numbers. But imagine the time when the first mechanical calculator was created. These calculators couldn't even outperform humans, but they seem to be very remarkable. And some people would even say that something like modern electronic calculators is simply impossible. That would be like magical technology to them, and they could also call it like artificial intelligence, but because it's outperforming humans, and at that time it was hard to imagine that a machine can outperform humans in complex computations. Another example, which is much closer to our time, is chess. And I personally vividly remember the first time a computer beat a human world champion. It was really shocking. I think it was all newspaper covers, and The Economist wrote something like this: if your job is similar to chess, prepare to lose your job. So everyone was thinking that there would be a lot of implications of this event. But nowadays, on my mobile phone, I have a chess engine that could easily outperform any human, and we don't really think it's so remarkable. We don't call it like really AI. We sometimes call these chess engines AI, but we don't really think it's like real AI. And I also believe that in the future we also would be thinking that large language models and all these chatbots, they're not really smart enough to be considered as AI when we just get used to the fact that all these tasks that they are doing now can be easily automated. Now I want to talk about a history of one specific AI task. And I think this task is really interesting. This task is image recognition. And why it is interesting is because unlike chess, which require you to have specialized knowledge and skill, this is something that humans do effortlessly. For example, if my son sees a couple of images of cats, then he would be able to easily recognize that this is also a cat, and this is a cat, and this is a cat. And even if I poorly draw something like this, he would still tell me that this is a cat. But if I ask him what's 2 plus 3, he wouldn't be able to answer this question because he's just 2 years old. So for him, math is very complicated, but he can effortlessly solve this task that we were not able to solve by computers until recently. And the reason why it's complicated for computers to do that is that it's hard to come up with an algorithm that would do this classification, right? We cannot actually rely on color because color can be so different. We cannot rely on shape because shape also can be so different. We cannot rely on body parts. For example, if we say, cat is something with a tail, then we would fail to recognize that this image is a cat. And, similarly, if we say that cat is something with nose and eyes, we would not be able to recognize that this is a cat. And again, for humans, it's very easy. You can directly see that all three of these images are images of cats. You cannot rely on texture. So yeah, it's kind of a complicated task. But people were trying to solve it for quite some time, actually from early 60s, and that's when the whole field of artificial intelligence emerged. And they started with simple tasks, using like photos of simple objects, and we're trying to identify contours, and from these contours trying to identify object or its position, its direction. And they were creating more and more complicated models, and they achieved some progress. And to measure this progress, in 2010, a competition was created that was called ImageNet. So in this competition, you have these photorealistic images, and then you have to guess what's on this image, and you get 5 guesses. If at least one of these guesses is correct, then it's considered that you recognize the image. And in 2010, the performance of the best model was a bit lower than 30%. And then it was like slowly improving, so people were building upon previous algorithms, making more complicated algorithms. Then something happened in 2012, and the performance significantly dropped, and then quickly computers outperformed humans. What was interesting is that the ideas behind this 2012 algorithm were not built upon previous ideas, it was something new. So what was new? So the idea was, instead of saying that cat is something of a certain texture, certain shape, etc., you just say that cat is something that's similar to all other images of cat and not similar to all other images of dogs or mugs or hats. So this idea seems like simple, so you might be wondering why people were like so stupid before, why they didn't use it before. And the reason was that there was just not enough data. So I think since 80s, the amount of digital data started to be compared to the amount of analog data. So it was like growing and growing. So this plot ends in 2007, but what we had in 2007 is nothing compared to what we had in 2021. And so before we have all this digital photography, all these images of cats, this approach just couldn't work. And the another reason is that it also required a lot of computational resources. So for this approach to work, we also needed to have a lot of computational power, and it was like steadily growing according to Moore's law. And this approach is actually called machine learning. So the idea of machine learning is that, instead of just trying to write a deterministic algorithm that would perform certain operations and would come up with an output, it's a cat or a dog, you just make this algorithm to rely on data. This data is called training data. So you train your algorithm on this data, and then once it's trained, you can apply it to a new data sets, to new unseen data. And now we'll talk a bit about machine learning and how exactly it works.